This module is about rational function, but number one, we just want to go back and review rational exponents. So rational exponents and radical expressions, they are related. So first, let me just write down the form for you. So a to the m over n power is just like a to the m, and you take the root, the n root. Okay, so when you have a to the 2 over 7th power and you want to rewrite, so we have a square, and then the index is going to be 7. So the index, that's going to be the denominator, and the numerator is the power. Okay, so same thing over here. We have 32, and then you want to simplify to the 2/5 power. Now notice that this one right here, we can definitely do this first and then you square it, because by power rule, when you take the power of the power, you multiply the exponents. I want to take care of the numerator first, because when you take care of the numerator, the number gets smaller. So this is just like the 5th root of 32, and then you square it. So if I take the 5th root, that would be 2, and you square it, that would be 4. So always take care of the numerator first. Always take care of the denominator first. All right, now we get into rational equation, rational function. We learned about rational function, so let's take care of rational equation. So you can see right here we have two fractions. When you have two fractions and they're equal, we have a proportion. So you just simply cross multiply. So when I cross multiply, I ended up with negative 14 times x, negative 6 times x minus 4. And then from there, you simplify it. All right, so you can see that this is back to linear equation. So I want to proceed as linear equation. The most important thing of rational equation is when you solve it, you're going to have to check your solution. So make sure your solution cannot be 0 or 4, because these two will make the denominator equal to 0, and we don't want the denominator to be 0. This case, we have x equals to negative 3, so we don't have to worry about it. Now, moving on to number 4, you see we have to solve for b. You can just multiply everything by the LCD if you want to get rid of the fraction. So if I don't want to work with fraction like this, I can always multiply by the LCD. So the LCD in this case is 4b. So if I multiply everything by 4b, the first one is gonna give me 7b. And then I have 20. And then the last one, I have 8b. All right, so we're just gonna solve for it. So I'm gonna add 8b. So b is 20 over 15, and if you want to reduce it, it's gonna be 4/3. Okay, once again, b cannot be 0 in this case, but turn out b is 4/3, so we good. All right, now same thing over here. Like I said, you can multiply everything by the LCD. So in this case, the LCD is 6y. So the first one, I have 15. The second one, I have 14. And then you multiply 6y by 1, you get 6y. So we have 1 equals 6y. So y is 1 6. Okay, in this case, y cannot be 0. All right, number 6. So for number 6, the LCD is v minus 3. I'm just going to write down the values that not in the domain, so v cannot be 3. So we get 6 minus 4 equals to 2 times v minus 3. So 6 minus 4 is 2, and then I distribute this part. I add 6 over, which is 8, 2v, so v is 4. All right, straightforward. Now let's try some application problems. When it's come to application problems, so you see for rational, there are many types. The easiest type of rational would be proportion. So you see right here, we have Keisha runs 7 miles in 80 minutes at the same rate. How many miles would she run in 64 minutes? When you read the problems, you can tell this is proportion. And for proportion, all you have to do is line up the unit. So if I set up 7 miles for 80 minutes, then over here, I better get miles over minutes. Okay, we do have 64. So miles, how many miles? That's x. And then once again, you can just cross multiply. So 80 times x equals to 64 times 7. So when you make sure you have the units there. So 5.6 miles. Okay, you see, have you noticed that for 5.6 is smaller than 7? 64 is smaller than 80. That's the beauty of proportion. Proportion is straightforward. Now, the next type of application problems is one of my favorite. You have something called working together. Working together is when you see two things working together, two people working together. So you just have to go with the rate. And it's really simple. So it takes two computers 5 minutes to send out a company email. If it takes the slower computers, so we have the slower, and we have the faster, and we have together. Okay. Now, it takes slower computer 15 minutes to do the job. That means the rate of the slower is going to be 1 over 15. How long will it take the faster to do the job of its own? So we don't know, so it's going to be 1 over x. Together, it takes two computers 5 minutes, so it's 1 over 5. So that's going to be the rate. Now, because they are working together, we can just add them up. So we have 1 over 15, which is the rate of the slower. The rate of the faster is 1 over x, and the rate together is 1/5. Once again, I can just solve this by multiplying everything by the LCD. And in this case, the LCD is 15x. So what we have, x plus 15 equals 3x. So if I subtract x over, I get 15 over 2x. So x is 7.5 minutes. And it makes sense because that's the faster, the slower is 15 minutes, so the faster is 7.5. And of course, if they work together, it has to be the fastest, which is 5 minutes. So that's work problem. Every time you see working together, that's how you set up your problem. For this type of problem, we do want to make table. So what we're looking for is the rate of the rowing team. So I'm just going to call that the variable. We do know the rate of the current, which is 3. Okay, so we have two scenarios. We have rowing with the current and rowing against the current. So I have to make the table with the current. Every time you see this type of problems, it's a motion problem, so we know that we have to deal with D equals to RT. So I'm going to have R, I'm going to have T here. R times T is D. Okay, so with the current, I have X plus 3. Against the current, I have X minus 3. That's the rate. Now, the rowing team rows 60 miles, so I have 60 miles with the current. And I have 30 miles for against the current. Now, the time, we don't know, but you can solve for it. So, D equals to RT. Therefore, T has to be D over R. So, D is 60. R is X plus 3. 30, X minus 3. Now, we need to write the equation, and the one piece of information we haven't used is in the same amount of time. So, they travel in the same amount of time. So, I'm going to put the time, and we set the time equal to each other. Now you have a proportion problem, so you can just simply cross multiply. $30x plus 90. I'm sorry, I'm running out of room, so I'm going to put 30x here. So when we divide, I'm going to get 9. So that's the rate of the team. All right, moving on to number 10. Okay, so you see right here what we have is 7u minus 5 and u plus 5. This is the one thing I want you to do right away when you see a quadratic. So you factor right away. Now, just like other problems, we're going to multiply everything by the LCD. In this case, it's u minus 5, u plus 5. So if I multiply the LCD for the first one, I'm going to cancel out the u minus 5. By the way, when you multiply the LCD and you still have the denominator, that means something wrong. So your LCD is wrong, or your calculation is wrong. So the second thing, fraction, u plus 5 cancel out, so I ended up with u minus 5. And the last one, I have just 7. Now the problem got so much easier. It's just linear. So what I have is u equals 4. Once again, make sure you check u cannot be 5 and u cannot be negative 5. But we got it. U is 4. So no worry. Okay, moving on to number 11. Oh, this is simple. We just cross multiply. But when you cross multiply, we ended up with a quadratic. So if you have quadratic, you're going to try to factor, complete the square, or use quadratic formula. Okay, I'm going to move everything to one side. So hopefully I can just factor. Yes, so x plus 9 and x plus 6. So the answer is -6 and -9. Once again, we don't have problems with the denominator, so we can just keep these two values. All right, so the next one, the LCD, is x minus 2 and x plus 1. So I have x minus 5, x minus 2 cancel out, so I have x plus 1 for the first one. You multiply 1 by those two, so stay the same. And then the last one, I have x minus 7 multiplied by x minus 2. Now we have a lot of parentheses, so you're going to have to FOIL everything and move everything to one side so we can get quadratic. Hopefully I don't make any mistake. All right, let's keep everything to one side. So I'm going to subtract x squared, add 9x minus 14. Equals 0. All right, let's just factor. So if I factor, I ended up with x plus 7 and x minus 3. So x equals to -7, x equals to positive 3. Once again, we only have problems if we have x equals to 2 or x equals to 1. But -7 and 3, those are good points. All right, this one's similar to the previous problems. So once again, I'm going to multiply. So hopefully you recognize that x squared plus 7x plus 12 is x plus 3, x plus 4. So if I multiply by the LCD, that would be the LCD. So for the first one, I ended up with x times x plus 4. Second one, I have x plus 3 multiplied by 9. The last one is x minus 5. All right, let's keep in mind that x cannot be 3 and x cannot be 4. All right, let's just simplify this. Plus 27. I'm going to subtract x plus, let's just put subtract x plus 5. So we have x squared plus 12x plus 32. So x plus 8 and x plus 4. Okay, my bad. We are not allowed to have x, -3 and -4. Okay, so we solve it. X equals to -8, x equals to -4. Uh-oh, we have the problem right here, so you have to cross it out. So we only keep x equals to -8.